Slicing an array and common operations. After understanding what slicing is about and common operations that we can do on pieces of an array, we'll apply it to a mechanical system. As far as slicing is concerned, we are going to look at pieces of an array. Not an entire array, but only specific elements. Why? We could want to simply replace pieces by other ones, or interchange pieces, or remove pieces, but there are some rules to follow, and last, copy pieces into another variable. Now caution, it does not necessarily mean delete. We can look at pieces, copy them into different variables, we can change them by other pieces, but slicing is not synonym of deleting. There are rules to follow when removing and replacing arrays. It all comes down to keeping your matrix rectangular. Don't make an array non-rectangular by removing a piece in the middle. Or don't make an array non-rectangular by trying to replace 2 pieces by 5 of them. So as long as you make the dimensions consistent and be a rectangle in the end, all will be good. As far as the operators that are used, brackets, colons, commas, and parentheses. We have 2 variables ready in the workspace. One is a vector, scores, one is a matrix, table. Now I purposely hid the amount of element in scores. There's a 0.7, a 0.6, 0.6, and a dot dot dot. The scores are sorted. The top score is 0.7, but we don't necessarily need to know how many elements are in an array when we want to take pieces out of it. There's a couple keywords that are very friendly. Now we've already sort of sliced before when we are referencing an array. For example, the top score would be the first element. The top 3, at that point, we would be slicing. If I want the top 3 scores, I want to ask for element number 1, 2, and 3. So I ask MATLAB to count from 1 to 3 by increments of 1. If I wanted the last score, without knowing the actual number of elements, the keyword end, much like end on our keyboards, brings us to the end of something. MATLAB knows that it's the end of the vector scores. So the last scores is 0.16. Now we don't necessarily need to extract consecutive numbers, the top 3, the last 2, but we could extract, for example, the first and the last. I would still need the variable name first, parentheses no matter what, but inside here I want the first and the last score. As you can see, I had to add brackets. The first score is 0.7, the last score is 0.16. I can also reverse my order using slicing. So if I wanted to go from the end to the first element, all I would have to remember is putting my increment of -1. So right there I'm asking for all the elements to show up. So we're going to all of a sudden see that there are 9 elements in my array. Columns 1 through 6 and columns 7 through 9. If I wanted the last 2 scores, I could of course go 9 colon -1 colon 8. Now that I know that there were 9 scores, that would give me my last 2 scores. But keep an open mind that this could be an actual software and the high scores could change constantly. So if I want my last 2, I would much prefer going from end to end -1. That would be my last 2 scores in reverse order. Slicing really doesn't have to be consecutive nor kept in order. I could very well extract the 6th score first and the 2nd score second. So the 6 and the 2 are out of order. That's okay. I want to know the 6th score first. That was 0.45. And then I want to know the second score, 0.68. None of the examples here have deleted anything from my vector scores. It's still like it was on the first day. If I actually want to delete, for example, I want to delete my last score, I will put the delete brackets. Actually, I will lose an element. I went from 9 elements to 8 elements. And finally, if you want to replace. Suppose you want to replace element 4 and 5. I would have to give MATLAB 2 values. Well, let's put 0.62 for the 4th score and 0.5 for the 5th. If I look at 2 pieces, I replace it with 2 pieces. If by mistake I tried to add another score in between, MATLAB would tell me that I need the same number of elements on the left side and on the right side. So that's the idea behind slicing a vector. You can do the same thing with a matrix. As far as referencing a table, we need 2 coordinate systems. So for example, if I wanted the middle element of my table, it would be 2, 2, second row, second column. So as far as referencing an entire row, so slicing an entire row, I could do top row, for example, equals table. Which row do I want? Number 1. Which columns do I want? All of them. I could do the same thing with bottom row, keeping in mind that it might grow again. So the bottom row would be the end row, all columns. If it works for rows, it works for columns. I could do first column equals table, all rows in the first column. I could do last column, table, all rows in the last column. The order that's important here is that first indicate the position of the rows that you want, and second indicate the positions of the columns that you want. And again, there's no need to be consecutive. Let me show the table again. If we just want the corners of my table, always start with the variable name first, parentheses, the basic. From my table, comma, here you'll put the rows, here you'll put the columns. So rows, which rows do I want if I just want the corners? Well, I want row number 1 and the last one. Which columns do I want? Column number 1 and the last one. So all of a sudden, I have my corners extracted. This can work for 3D, 4D, 2D, anything that is a matrix. And I can reverse the order as well. Reverse the corners, for example, table, and 1, and for the columns as well, and 1. That would reverse my numbers. So that concludes slicing both in 2D and in 1D with the vectors. Remember that it's just a combination of XY coordinates of the pieces that you want. Now what operations can be done? Very simply, when you have a vector or a matrix and you're looking at the pieces that you want, at the elements that you've chosen, we can do on vectors sums. Sum of all the elements using sum of V. Multiply all the elements using prod for product, or calculate the average using mean. Now the trick is average does not exist. Mean is what we use. For matrices, it only operates on each column. We're going to go see what that means immediately, but that means we're going to have to do the operation twice. First on the columns and then on the result. Again, starting with scores and table. Scores was a vector, so if I do the sum of scores, MATLAB will just understand add all the elements. Same thing with the product of all my scores, or the mean of all my scores. So MATLAB just understands that you want to do that operation with all the values inside that vector. Now for a table, it's a little bit different. MATLAB doesn't actually add all the numbers. Like I said before, it adds all the numbers in a specific column. So 3 plus 7 plus 1 is 11, 4 plus 6 plus 2 is 12, and so on. Do the operation twice. Sum of the table will actually give you the sum of all the numbers. You can also combine that idea with slicing if you want to slice all the elements of the table and sum them second. So there's a way around doing the operation twice. Same thing for product. If you do the product of the table, it will be on each column. 3 times 7 times 1, 4 times 6 times 2, and so on. We can do the same idea to actually get the product of the entire table, or use slicing and the result is the same. Mean, same thing, each column. If you want the mean of the whole table, choose your method. Credit to the pizza picture and then lessons learned. Use the colon to slice pieces out of an array so that they can be used in regular operations. Pieces do not have to be consecutive. In that case, we will use the brackets and the specific index that we want, and we can even reverse the orders. Now sum, prod, and mean, there are many more functions, but if they're applied to vector, it applies to all the elements. If they're applied to matrices, they apply only to each column. So repeat the operation if you want to, or use the colon to refer to all the elements. Now this is the basic. You can replay it if you want, or we can actually go see an example with mechanical systems.